So, hello and welcome to my final year project demonstration video. In this video, I'm just going to be demonstrating my whole final year project, um, and hopefully I can clear up any issues if something wasn't really clear in the report. Hopefully it'll become more clear throughout this video. So, the way I'm going to do this video is I'm going to start off by demonstrating the app in its entirety and how it would work for a normal user. From there, I'm going to then uh, demonstrate, or not demonstrate really, but show the Firebase side of it, so how the storage is being done, and then from there I'm going to be showing the development of the neural network, and that was all done through Colab. So that's going to be the video. Hopefully I can do it within 15 minutes, but let's get into it. So at the moment I'm running an emulated Android device, and this is pretty much done all through Android Studios. So you might see here the Fat Wallet app. So this is the app I designed. You can see it's got its own little unique logo. So if I click into this, I should be greeted with a splash screen. So the last 1 or 2 seconds, and then I have the ability here to log in. But as a new user, they're not going to obviously have an account. So to fix that, I can just press sign up, and once here, the user is asked to enter an email address and a password. Now there is validation done on these, same as the login, and this is done through Firebase, so they won't allow not valid email address. So if there's no @ or if there's no .yahoo whatever, it won't be valid. And same with the passwords. The passwords need to be at least 6 characters long in order to function correctly. So if I set enter an email address, so I'll say demo at video.com. And for password, just do test 123. Now, once I sign up, I shall be brought to the activity view. And as you can see here, at the moment, it's empty. And this is because there's been no predictions. It's a new account. So, stuff you can see here. So you can see this is the user's email address, just so they know that they're on their own account. And the user has 2 abilities then, so they can add a new prediction or they can log out. So if the user logs out, his account is turned off the app and he's brought back to this page. And then I can just log back into that account. So video at demo.com and test 123. Demo video. So that was some validation on there by the Firebase server, so it was able to see that there was no user in the database with that email address, so it wasn't going to log in. So now that the user is here, they have the other option then to add a prediction. Now this is done by pressing the add button here, and then they're brought to the prediction activity. And once on this prediction activity, you might notice something. So the red picture here, that can be clicked on, and the user can upload a picture of themselves. Now, from the report, I discussed that I haven't gone with the image recognition, or so the image model. This was due to a number of reasons. One is obviously the computational costs. It was taking a bit of time to resize the image and get it to scale for the model. And secondly, after asking a couple of friends and family, some of them said they might feel uncomfortable with uploading an image of themselves to the app, and I totally understand the concern around there. However, stuff that is not optional is the weight, height, and age fields. These need to be inputted, as this is the data that's being sent to the model. And something to note about these is weight is in pounds, height is in and height is in centimeters. This is just due to how the data was gathered from how the data set was gathered. As a lot of the data was in this kind of format, so to reduce the likelihood of any conversion errors or anything like that, I just thought I'd stick with the same format. So like I said, this is the data that's been sent to the model. So I'll just do a mock-up prediction. So let's say someone's 150 pounds, so roughly in about 60 kilos. They've about 170 centimeters, so about 5'8", and 21. So if I add this prediction, you can see there it's added, and the app's predicting somewhere around 13 to 15%, which is probably somewhat correct. So if I wanted to then obviously come in here, I can edit this prediction. I see it here, the image loads and everything. Took a bit of time there because it's been loaded from the Firebase server. As once the image is there, it's uploaded, so the user can delete that image off their phone. Now, the reason why I have the images optional is I think it might be a nice feature. If a user does want to check their progress, they can check what they're like at different body fat percentages. So I thought it'd be a nice feature to have. And now I just want to show that there's some variance there. So, like I said, the image isn't required. It just looks nice on the app, so I'll leave it in. So, if someone was to be a bit heavier, so let's say 200 pounds, so that'd be near about 100 kilos, same height as before, and maybe the same age, we should see it might be a slightly higher body fat percentage as you'd expect. And that seems to be true. They're predicting about 19 to 21%. So yeah, and it's not just dependent on the body fat percent or on the weight. So it also works on the height as well. So going off the first example again, so 150 pounds. Was that the one I done for first? So I can go back here. Yeah, so 150 pounds, 170 centimeters. So if I come here, type in the 100 same again. So 150. Let's say this person is now 220 centimeters. I would predict that they'd have a slightly lower body fat percentage as they're obviously taller. Yeah, that seems to be what the app's predicting there as well. So you can see this time there's no image uploaded, so it's just blank for this prediction. If that could be what the users prefer, but they can just come in here and then upload the picture if they wanted to. So that's how the app works.
Bringing on from the Android app, I just want to quickly show the database. Now, like I said, this is all done through the cloud, and I done it through Firebase. It's very handy, all free, and this is all linked with the application. So this is what the database will look like. Now, you can see here the first column here is the users, and then there seems to be a random string here. This is their ID, which is just randomly generated by the app. So for the account I just created a moment ago, you can see here inside of their user ID, we have another kind of column, and if we click into this should have the predictions. Now, so as you know, we made two predictions, both with different weights. So one of them was 150 pounds, and the other was 200. And so this is just how the data is stored. You can see it's very nice and easily stored. This random string again, this is to help Firebase identify the predictions. So every prediction again will then have a unique ID. So you can see here, this is how I decided to store the data. So you have the age variable, body fat. This again is just a unique ID, and that's just the unique ID then of again the prediction. The height, so the height of the user. The ID, I don't know what that's there for. I thought I took that out. Then we have the image. Now I have a separate storage for images, so if users decide to upload an image, that image is then sent to it's saved on the cloud, so it's not actually saved locally on the device. And I was getting some issues with this, whereas if someone was to delete the image off the phone, then they'd load up the app and the image wouldn't be visible again. So for the convenience of the users and for better user experience, I decided to have it all cloud-based. So you can see here for this image, there is a link. If I open this, it should take me to view the image we uploaded. And this is all done through Firebase cloud storage now for the images. But this is how it's linked, and that's the image we would have uploaded to the app. So yeah, that's pretty much the basis of the database. It's very nice, very convenient, and it's easily manageable. If I want to delete a user, I can come in here and delete a manually. The first part of the notebook is obviously all the imports to the project. Secondly, this was the only sort of disadvantage, I suppose, to the using Colab, is because it resets every couple of hours, as the premium version, which you can pay for, which I haven't been, but the premium version allows for longer run times of 12 hours, but if you run anything over 4 hours, it cuts out and you have to reset it all again. So that was the only issue I would have had, but it was perfect for this project. So first thing, I have to import the data file, and to do that I have to import it from my cloud storage. So I just have the dataset up on Google Drive, so the same one that's in the report. So it has the images of the users all in unique ID, so starting at index 1 and going all the way up to whatever the newest number is. And then it also contains the user text file, which the user who has the image number 1, he is related to the first line of that list, so his data is related to the first line on that list. So as you can see here, so this is just reading the column names. So as the user text file has gender, age, weight, height, range, and body fat. These are the columns I've set. Now some of these will be dropped later on as they're just not useful or there's not enough information in them. And then yeah, so that's pretty much just reading that in. I then just done a df head just to make sure it was the correct date and there was no issues with it. Which you can see there, it all seems to be okay. And then because I know the dataset has 325 entries and 6 columns, I done df shape, and that confirmed what I expected it to do. And then obviously I kind of want to check to see if there is any missing values, as these wouldn't be compatible with the neural network. So simply done by just seeing if there's any, by doing df.is null.any, and you can see this returned that true, so there was some null values for body fat. So to fix this, I just dropped all n of the NA values from the data frame, and then just to confirm there was no more null values, I just done df.is null.any, and you can see they're all false, so that means all the rows at the moment are clear. Next, I wanted to make sure that the types of the columns, so age, weight, height, and all that, they're in the correct format. So you can see there that gender is an object because it was obviously a character. That makes sense. We have age as an int. That makes sense. Weight as an int. That makes sense. Height as a float. That's what I expected. And range as an object, which is what I expected as well because it's a string, so that couldn't be an int at all. And then I have body fat, which is a float, which is also what I expected. So I should just skip this part, but yeah, this is just going through it first. So when I first ran this, height was taken in as a string, so I just needed to convert that then to a float, and that's what this piece of code is doing here. So it's converting the height column to be as type of float. And so I decided to drop gender and range straight away because first off, there was no entries for female. This was due to the limited availability on the Reddit page. So because there was no other fields, it was just all males. There was no need to have it, so I was able to drop that column. And then range, because I wasn't using the range for a model, it wasn't going to be used anywhere. I decided to drop this because I already have another variable called body fat, and this is much more useful, and this is what the neural network will be using. So that's my main reason for deciding to drop range. So here, this is how I read the image in. So again, it's just been read in from my G drive. So it's going through here. It's going, just make sure they're all JPEG. I'm using CV2 to read them in. So here I'm resizing the image to be 200 pixels wide by 200 pixels long. This is done just to make sure all the images are in the same format, because some images might be a lot bigger resolution and that would cause issues later on down the line. And I'm also changing the images to grayscale. My main reason for doing this is there's 3 times less detail So originally I would have thought, this would obviously lower the training time and the computational cost. Um, and you can still predict someone's body fat percentage visually by looking at them, even if the image is black and white. Yeah, so here then I'm just adding all these to an array, and I'm just resizing the images. So I'm dividing it by 255 here. So this will have all the values in between the range of 0 and 1, as 255 is the maximum pixel value for the image. So dividing this by 255 has all of them in the same range of 0 to 1, and this will be a common theme then throughout all the other inputs to the network. So to try and make sure everything was uniform and in between the ranges of 0 and 1, I had to obviously get the max value in each of the columns and then divide every other value in that column by the max one. And as you can see, I was just done here by doing just the dot max function on the column, which is very useful. And I was just able to divide the whole data frame by that max value. So this will then set all the values in each of those columns to range between 0 and 1, and this is then just to keep it more in line with the images and just make it a lot easier. So the next bit is to create the model, I suppose. So there's two bits here. So there is the multi-layer perceptron, and this is for the numerical and categorical data, and the second part is the CNN. So this is the convolutional neural network, and this will be taking the image as an input. So as you can see, the MLP it's quite short, because it's only taking in numerical data. It's just got an 8 dense layer, so as the with the ReLU activation, and then we've got a 4 neuron layer, and that's it for the MLP. For the CNN, because it's working with images, it's a bit more complicated. It needs to take in the width of the image, the height of the image, the depth. So how many is it using grayscale? So in my case, that would just be 1, or is it using full RGB? So that'd be 3. So it's similar enough in the way it works. So it's just I'm just setting up the layers. I'm using the format, so the 200 by 200 pixels to set up the inputs. Then I'm just using the hidden layers, and then that's outputting a prediction, and that's being returned. So now that that's created, it was time to split the data. Because I didn't have a enormous amount of data, I didn't do a 50-50 split, so that would be more ideal. Instead, I had to do a 75% of the data was dedicated towards testing, and 25% of the data was dedicated towards validation set. So this again was just done using train test split, and that was able to split the data. So I had to split. So this is just splitting the numerical categorical data, and then calling the function above, I set the input to be the shape of the training data. So that would just be the age, weight, and body fat, or age, weight, and height. Sorry. Next was time to create the CNN. So that was done by setting it by 200 pixels by 200 pixels, and then 1 for the grayscale value. Then these were both joined together in order to create that multiple input neural network. So it contained inputs for both numerical and categorical, and also image data. And then just to add on to that, then I added a couple more dense layers, and then that was able to that was the full model then created, and that is the diagram that can be seen in the report. Okay, and so then this is just going through the model fitting. So it's for the data, it's using training images, and then y train is just the expected output value. So at the moment, this one is the image only neural network that I'm using. Um, that's again, it's visible by the graph. So I decided to run them all for about 150 epochs, and as you can see, so this is the training loss. So this is how accurate it is on a training set, and this is how accurate it is on a validation set. So after about 150 epochs, it was down at about 15% error rate on the training and 25 on the validation. Yeah, so this is just me printing out, just get a list of the training and validation, just so I could make the graphs from. It was a lot easier to do it this way instead of putting all the variables in by hand. This one is just fitting the model for numerical and categorical data. And again, this is just run for 125 or 150 epochs. And as you can see there, lost about 20%, so it's about 5% higher than on the training. But it was actually a bit less than a percent lower, or about a percent lower than the on the validation. So it was a bit more accurate at predicting unseen data. Again, this is just printing out a list so it can be used within the graphing. And finally, this is using the combined input, so using the model which has the image data and the numerical data as the inputs, and just to see how accurate that one is. So again, it was run for 150 epochs, and you can see there it's about 24% on the validation and 12% on the loss. So it was the best at learning on the training, but on the validation it was 24.5, which is a little bit worse than the numerical and categorical data on its own. Again, that's just printing out. So printing out that data was done so I could form these graphs. So this is the number of epochs. So they were all run for 150 epochs. So that's going on the x-axis. And then on the y-axis, it's how much it would, or the training loss. So as you can see for the image data, it went down and then it just spiked up over 300 and then it started to gradually go back down again. And that's the same then for this is the training loss. This is a much nicer graph, it's more visible, and you can see the clear divergence there. And then to end, this is how the model was then saved.